Good afternoon and good day to my respected teachers, esteemed judges, my fellow students and the audience. We are Group 3 and my name is Sally Megan. Today we will be presenting our innovative project titled Passive Energy Harvesting Public Seating. The idea behind this project is simple but powerful. Every day, thousands of people sit on benches in campuses, parks, bus stops, and public areas. These benches serve only one purpose: sitting. Our project asks a different question. What if these benches could do more? What if they could generate energy while people simply go about their normal activities? This project focuses on sustainability, smart infrastructure, and practical innovation. Throughout the presentation, we will explain design feasibility, technical mechanism, and real-world application of our idea. This slide introduces the members of our group. Our team consists of 6 members, each with specific roles and responsibilities. I am the team leader, overseeing coordination and overall direction. Mariam is our deputy team leader, supporting planning and organization. The remaining members contributed to technical research, feasibility analysis, market study, surveys, documentation, and design. This project was not the work of one person, but it was the result of collaboration, discussion, and shared problem solving. Each member contributed ideas and efforts to ensure the project is innovative, realistic, and academically sound. Here, we show how tasks were divided among the team. Task division was essential for effective project management. Each member was assigned responsibilities based on their strengths, such as technical design, feasibility studies, survey creation, data analysis, or report writing. This structured approach allowed us to manage our time efficiently, avoid duplication of work, and ensure consistency throughout the project. Regular discussion helped us integrate individual contributions into one cohesive solution. This slide presents the structure of our presentation. We will begin with an executive summary and product introduction. Then we will discuss the market need, business model, and societal problem. After that, we will move to technical design, feasibility analysis, and system mechanism. We will also present survey findings, implementation plans, risk assessments, and future recommendations. Finally, we conclude with learning outcome, case studies, our project report, and acknowledgements.
Every day, people sit on benches across campuses and public spaces. They wait, they rest, they scroll on their phones while their battery slowly dies. At the same time, sunlight hits those benches, body heat is released, and movement happens constantly. All that energy is there, and almost all of it goes unused. This project starts with a simple question: what if a bench could do more than just sit there? This innovative project introduces a passive energy harvesting public bench designed to quietly generate renewable energy while remaining part of everyday life. Instead of relying on a single energy source, the bench integrates multiple harvesting mechanisms to make use of what is already available in the environment. Solar panels capture energy from sunlight. Thermoelectric generators convert body heat into electrical power, and piezoelectric elements generate energy from pressure and movement when users sit or shift on the bench. Individually, each energy source produces only a small amount of power. However, when combined through a carefully designed system, these small contributions become meaningful. The harvested energy flows through a power management and regulation unit, ensuring stable and safe operation, and is stored in an internal battery system hidden within the bench structure. This stored energy is then used to power practical features that users immediately recognize. USB charging ports allow devices to be charged while waiting or resting. Low-energy LED lighting improves visibility and safety at night, and optional wireless charging enhances convenience without adding complexity. Importantly, users do not need to operate or control the system. The bench functions normally, while energy harvesting happens silently in the background. Beyond convenience, the bench serves a larger purpose. It demonstrates how sustainability can be embedded into ordinary infrastructure without changing human behavior. People do not need to learn something new or act differently. Simply by using the bench, they become part of a renewable energy system. In conclusion, the passive energy harvesting public bench transforms a familiar object into an intelligent, sustainable solution. It shows how small-scale renewable technologies, when thoughtfully integrated, can add real value to public spaces. This project is not about replacing traditional power systems, but about rethinking everyday design and proving that innovation can be both practical and quietly impactful.
Hello everyone, we're here today with Mr. Mfaume, who is a construction engineer, for an interview, a written questionnaire that we already sent. Welcome, Mr. Mfaume.
Hello, I'm Mr. Mfaume. I'm a construction engineer who regularly works in the public and outdoor environments and relies heavily on mobile devices for data coordination and communication. My responses are based on practical experience with public infrastructure and real usage needs.
To start it off, Mr. Mfaume, can you tell us your age group?
My age group is between 54 and 57.
Which of the following best describes you as written in the questionnaire?
Public commuter. My works require frequent movement between sites and public transport, making public infrastructure relevant to daily use.
Off to the next section in our questionnaire. How often does your mobile device run low on battery while you are in public spaces?
Often, extended site hours and continuous phone usage for calls and documentations contributed to frequent battery drain.
Have you ever needed to change your phone in a public place but could not find a power source?
Yes. This commonly occurs at transport hubs and outdoor environment locations where charging facilities are limited.
And Mr. Mfaume, how important is access to charging facilities in public spaces such as campuses, parks, or transport hubs?
Very important. Reliable charging access improves efficiency and reduces dependence on carrying power banks.
How useful would a public bench with built-in charging ports be to you?
Very useful. Combining sitting and charging allows productive use of waiting time in the public areas.
Thank you. Off to the next section. Would you use a public charging bench if it is available in your area?
Yes. Availability and convenience would make it a practical option during daily travel.
Oh, and would you be willing to pay a small fee to use public charging if the service is reliable and convenient?
Yes. Paying a small amount fee is reasonable if it ensures consistent service and proper maintenance.
What pricing option would you consider reasonable for public phone charging?
A low-cost fee for approximately 20 to 50 cents per 15 to 30 minutes. This pricing balances affordability and sustainability of the system.
Okay. Would scanning a QR code to activate charging be acceptable to you?
Yes, comfortable. QR code payments are already commonly used and require minimum efforts.
Now let's talk about location and design preference. Where would you prefer these charging benches to be installed?
Transport hubs and university campuses. These locations have high foot public traffic and longer waiting periods.
Would you prefer a bench with a solar canopy that provides shade?
Yes, shade improves comfort, especially in outdoor environments, while supporting renewable energy use.
How likely are you to use a shaded solar-powered public bench compared to a normal bench?
Very likely. The added functionality makes it more attractive and than a conventional seating.
Okay. Do you believe solar-powered public seating contributes positively to environmental sustainability?
Strongly agree. Using renewable energy reduces reliance on grid electricity and supports sustainability goals.
Let's move to the next section. Overall perception. Overall, how would you rate the idea of a solar-powered public bench with phone charging capability?
Excellent. The concept addresses both functionality and environmental needs in public infrastructure.
Would you recommend the installation of such benches in public spaces?
Yes, the system will benefit users while promoting sustainable design practices.
Okay. Thank you very much, Mr. Faume, for participating in this survey.
Thank you. You are welcome.
This slide summarizes our entire project. Our passive energy harvesting public seating is designed for locations such as university campuses, parks, and public transport hubs. The bench integrates renewable energy technologies directly into its structure. The system harvests energy passively from sunlight, body heat, and human movement. The harvested energy is used to support low-power services such as mobile charging, the LED lighting, or small sensors. Most importantly, users do not need to change their behavior. They simply sit and energy is generated automatically. This makes the system practical, inclusive, and easy to adapt. This slide gives an overview of the product itself. The bench looks like a normal public seat, but inside it contains energy harvesting components, storage units, and a power management system. The design prioritizes comfort, safety, and durability. By integrating technology invisibly into everyday furniture, the bench encourages sustainability without inconvenience. At this point, I would like to invite our Deputy Team Leader, Mariam, to continue with the next section.
Thank you, Sally Megan. Hello everyone, my name is Mariam, the Deputy Team Leader. This slide introduces the energy sources used in our system. Our bench uses a hybrid energy harvesting approach, meaning it collects energy from more than one source. This includes piezoelectric energy from pressure, thermoelectric energy from body heat, kinetic energy from movement, and solar energy from sunlight. Using multiple sources increases reliability and ensures continuous operation under different conditions. Here we focus on two key sources. Piezoelectric materials generate electricity when mechanical pressure is applied. These materials are embedded in the seat and the backrest. So when users sit, shift, or lean, small amounts of electricity are generated. Thermoelectric generators harvest energy from the temperature difference between the human body and the bench surface. Since the human body is usually warmer than the surrounding environment, this temperature gradient can be converted into electrical energy. Both processes are passive, silent, and safe. Our vision is to create public infrastructure that is self-sustaining and environmentally responsible. Our mission is to integrate renewable energy technologies into everyday public objects in a way that is practical, scalable, and educational. We also aim to raise public awareness about sustainability through visible functional design. There is a growing demand for smart infrastructure in urban environments. People rely heavily on mobile devices, yet outdoor charging options remain limited. Existing smart benches often depend only on solar power, which reduces reliability during cloudy weather or at night. This gap in the market creates an opportunity for a hybrid passive energy harvesting solution. The top problem we address is the lack of accessible outdoor charging. Our business model combines public benefit with sustainability. In educational and public institutions, charging can be provided free of cost. In commercial areas, access can be monetized through low-cost QR code payments. This approach supports long-term maintenance and scalability. Compared to existing solutions, our system offers high reliability and better energy availability. By combining multiple energy sources instead of relying on only one, our bench performs more consistently across different environments. I now invite Ngozi to explain the technical aspects in detail.
Thank you, Mariam. Hello, everyone. My name is Ngozi. This slide highlights the technical features of our system. These include solar panels integrated into a canopy, piezoelectric pressure sensors in the seating area, thermoelectric modules, kinetic energy harvesters, energy storage units, and a centralized power management system. Each component plays a specific role in ensuring efficient energy generation and distribution. Energy collection begins when users interact with the bench. Pressure from seating activates piezoelectric sensors. Body heat creates a temperature gradient for thermoelectric generation. Small movements generate kinetic energy, while solar panels collect sunlight during the day. All these inputs are converted into electrical energy and routed to a central system.
The project is technically viable using proven technologies. It has low maintenance costs and offers long-term sustainability with potential capital recovery through micropayments.
This slide introduces technical feasibility. Technical feasibility asks an important question. Can this system actually be built and function in real life? Our answer is yes, because every component we use already exists in real-world applications. We are not inventing new physics, we are integrating proven technologies in a smart way. Let me explain this in more detail. Solar panels, piezoelectric materials, thermoelectric generators, batteries, and supercapacitors are widely used in consumer electronics, sensors, and renewable systems. By combining these technologies, we ensure redundancy. If solar energy is unavailable, pressure or heat harvesting still generates power. Energy storage systems stabilize output and supply energy when needed. The mechanical design is simple, which reduces wear, maintenance cost, and failure risk. This makes the system both realistic and durable. This slide explains how the system works internally. All harvested energy flows into a power management unit. This unit regulates voltage, prevents overload, and decides how energy is distributed. For example, lighting may be prioritized at night, while charging ports are regulated to prevent excessive drain. The system is modular, meaning each energy source operates independently. If one module fails, the other continues working. This improves reliability and makes maintenance easier. Components can be replaced without dismantling the entire bench.
The bench follows a modular step-by-step installation process. Theoretically, the prototype is tested under real conditions to ensure safety, durability, and functionality.
A pre-launch survey was conducted to validate user demand, usability, and feasibility before implementation. The survey assessed public charging challenges, willingness to pay, acceptance of QR payments, and preferred installation locations. We collected data from 120 respondents, mainly students and commuters, aged 18 to 34, using both online and on-site methods.
This slide presents findings from our user survey. The survey revealed that a majority of respondents experienced battery depletion in public spaces. Most participants expressed strong interest in public charging solutions. Importantly, many respondents were willing to use QR code payment system in commercial areas, supporting our proposed business model. Analyzing the survey, data confirmed both technical and social feasibility. High user acceptance indicates that the solution addresses a real need. The results also guided design decisions such as charging speed, location selection, and payment option. This data-driven approach strengthens the credibility of our project.
Hello everyone, my name is Sharfia. In this slide, I will discuss the advantages and disadvantages of the passive energy harvesting public setting system. Starting with the advantages, the most significant benefit is sustainability. The bench generates renewable energy without relying on fossil fuels or external power sources. Another advantage is that the source is completely passive, meaning users do not need to perform any extra actions to generate energy. They simply sit and use the bench as usual. Additionally, the system has low operational cost because once installed, it requires minimal energy inputs and limited maintenance. The bench also serves an educational purpose by visibly demonstrating renewable energy used in public spaces. However, there are also some disadvantages. The amount of energy generated per user is relevantly small, meaning the system is sustainable only for low power applications. The performance can also be influenced by environmental conditions such as weather and user traffic. These limitations guided us to design appropriate mitigation strategies, which I will explain next. This slide explains how we address the disadvantages mentioned earlier. To overcome limited energy output, we use a hybrid energy harvesting approach instead of relying on a single energy source. The bench combines solar, piezoelectric, thermoelectric, and kinetic energy harvesting. This increases overall energy availability. Weather dependency is mitigated by energy storage systems such as batteries and supercapacitors, which store excess energy for later use. Power management software also prioritizes essential functions to prevent energy waste. Finally, our modular design allows damaged components to be replaced individually, reducing downtime and maintenance costs. This slide presents the SWOT analysis for our project. The strengths include sustainability, innovative design, and low operating cost, and ease of integrated into existing public spaces. Weaknesses include limited power output and dependency on user presence. Opportunities include growing smart cities initiatives, increased demand for outdoor charging, and government support for renewable energy projects. Threats include vandalism, weather damage, and competition from commercial charging stations. This analysis helped us refine our design and anticipate challenges before implementation. This slide explains the project lifecycle from the start to finish. The lifecycle begins with the idea generation and problem identification, followed by conceptual design and feasibility analysis. Next comes the prototyping, testing, and refinement. Once validated, the system is deployed in selected public spacing. The final stage includes monitoring performance, collecting feedback, and implementing upgrades. This structured life cycle ensures long-term sustainability and continuous improvement.
The system consists of energy harvesting subsystems, power management and storage, and a modular layout for scalability.
Here we outline basic usage instructions. Users simply sit, connect the devices, and allow the system to function automatically. Visual indicators such as LED lights show availability and charging status. Safety features prevent overcharging and protect users' devices. The goal is to make the experience intuitive and stress-free.
This project supports sustainability goals, smart city initiatives, improved public space utilization, and enhanced user convenience.
This slide focuses on project delivery. The project was delivered through structured planning, clear documentation, technical diagrams, survey analysis, and presentations. Each phase was reviewed to ensure alignment with project objectives and academic requirements.
We followed a research-driven methodology involving user research, problem identification, analysis, validation, and project management frameworks. Implementation includes pilot testing, phased rollouts, monitoring, and scalable deployment strategies.
Here we outline basic usage instructions. Users simply sit, connect the devices, and allow the system to function automatically. Visual indicators such as LED lights show availability and charging status. Safety features prevent overcharging and protect users' devices. The goal is to make the experience intuitive and stress-free.
Here, we represent the activity plan and schedule. The project allows a timeline with defined milestones, including research, design, feasibility analysis, survey collection, and final presentation. Effective scheduling ensures timely competition and smooth coordination among team members. This slide outlines the project deliverables. Deliverables include the project proposal system, designable diagrams, feasibility studies, survey reports, and the final presentations. Each deliverable represents a key stage in transforming an idea into practical solution.
In this slide, we assess potential risks associated with the project. Technical risks include component failure or energy inefficiency. These are reduced by using proven technologies and modular components. Financial risks include installation and maintenance costs. These are managed through scalable deployment strategy and optional monetization. Environmental risks include exposure to rain, heat, and dust. To address this, components are enclosed in weather-resistant housing. Overall, the risks are manageable and do not outweigh the benefits of the project.
In this slide, we present recommendations and future work. We recommended pilot testing the bench into selected public areas to evaluate real-world performance. Future improvements may include LOT integration using informing analysis and improved energy storage technologies. This enhances future further increase efficiency and user engagement. We acknowledge our academic supervisors, survey participants, and institutional support. In conclusion, this project demonstrates how everyday public infrastructures can be transformed into sustainable, functional systems. The passive energy harvesting bench combines innovation, visibility, and social benefit. It promotes renewable energy awareness while addressing a real public need.
In this case study, our group explored the role of critical thinking in innovation and engineering decision-making. We discussed how critical thinking involves actively questioning assumptions rather than accepting ideas at face value. The discussion emphasized the importance of evidence-based reasoning, logical consistency, and minimizing emotional or biased judgments. We recognized that strong critical thinking skills are essential when evaluating innovative ideas, as they help prevent flawed designs and unsupported conclusions. Our learning outcome from this case study was that we learned how to systematically analyze problems, identify weak or unsupported arguments, and apply logical reasoning when assessing ideas and designs. This strengthened our ability to make informed and objective decisions throughout the project. This case study focused on how Samarkand's journey and highlighted how impactful innovation is often driven by purpose, persistence, and social responsibility rather than immediate success. We discussed how his work demonstrated the power of technology to democratize education and address real societal challenges. The case reinforced the idea that meaningful innovation evolves over time through commitment and continuous improvement. We learned that successful innovations often begin with identifying genuine social needs and requires long-term dedication. This insight encouraged us to design solutions that prioritize social impact alongside technical feasibility.
In this case study, we examine creativity as a structured and iterative process, rather than a spontaneous act. Our discussion highlighted stages such as preparation, examination, experimentation, failure, and retainment. This challenged the common misconception that creativity happens instantly and without discipline. We learned that sustainable and impactful creativity emerges through continuous iteration, reflection, and improvement. This understanding helped us approach innovation with patience and structure during the project. This case study examined the balance between creativity, exploration, and disciplined exclusion. We discussed how excessive focus can limit creativity while excessive exploration can result in a lack of tangible outcomes. Achieving balance between these two elements was identified as a key factor of success in innovation. We learned to balance creativity with practical focus, enabling us to explore innovative ideas while maintaining direction and deliverables outcomes during project development.
In this case study, we discussed how innovation thrives in environments that encourage collaboration, diversity, and psychological safety. The discussion emphasized that breakthrough ideas are more likely to emerge from collective effort rather than individual brilliance. We learned that successful innovation depends on teamwork, trust, and shared responsibility. This reinforced the importance of inclusive collaboration within our project group. This case study explored how unconventional or weird ideas are often initially perceived as impractical but can lead to significant breakthroughs when evaluated carefully. We discussed the importance of not dismissing ideas prematurely. We learned to remain open-minded toward unconventional ideas while applying critical evaluation to determine their feasibility and potential impact.
In this case study, we examined how innovation benefits from structured planning while remaining feasible enough to capitalize on unexpected opportunities. We discussed how rigid planning can limit innovation if adaptivity ignored. We learned to combine structured planning with flexibility, allowing innovation to evolve while still maintaining clear objectives. This case study focused on the importance of balancing long-term vision, present execution, and the ability to let go of outdated practices. We discussed how innovators must continuously adapt to remain relevant. We learned the value of strategic thinking across different time horizons, helping us plan for future innovation while effectively managing current responsibilities.
This case study explored how creativity often involves breaking conventional rules and embracing constraints. We discussed how limitations can stimulate innovative thinking rather than restrict it. We learned that constraints can enlarge creativity by encouraging problem solving and alternate approaches. In this case study, we analyzed how collective creativity emerges through collaboration, communication, and shared goals. The discussion highlighted the importance of teamwork in driving innovation. We learned that innovation is a team-driven process and that collective effort often produces stronger outcomes than individual work.
We reflected on how the passive energy harvesting bench integrates lessons from innovation theory and previous case studies into a practical solution. We emphasized balancing creativity with feasibility, ensuring the design was technically realistic, socially relevant, and environmentally responsible. We learned how to translate theoretical innovation concepts into a real-world engineering project, manage teamwork effectively, and design technology that serves both user needs and sustainability goals.
These slides present our meeting minutes, which document how the team planned, discussed challenges and made decisions and tracked progress. They reflect our structured collaboration and accountability and continuous communication through the project lifecycle.
Through this project, I developed strong strategic leadership skills by integrating creativity, innovation, and leadership to guide the project from concept to completion. Case studies taught me that innovation is a structured process rooted in real-world problems. I also strengthened my project management abilities, including task coordination, conflict resolution, and maintaining team motivation throughout the project lifecycle.
I learned to critically evaluate complex arguments by identifying assumptions and distinguishing between correlation and causation. Case-based learning helped me appreciate the value of unconventional ideas when paired with logical arguments or evaluation. As deputy leader, it strengthened my ability to support leadership through collaboration, adaptability, and strategic alignment.
This project enhanced my ability to critically assess information and recognize cognitive biases. I learned to test creative ideas against practical constraints such as usability and sustainability. Additionally, I developed a deeper understanding of how trust, communication, and shared responsibility foster effective innovation within teams.
I learned to adapt deliberate thinking habits by analyzing problems systematically and breaking them into manageable components. Case studies showed me that creativity requires discipline and iteration. I applied these lessons by contributing constructive feedback and supporting collaborative decision-making within the group.
I developed strong argument evaluation skills, including identifying logical fallacies and assessing evidence credibility. Case studies taught me that innovation is incremental and requires openness to feedback. I also learned that leadership is role agnostic and that shared responsibility strengthens teamwork and innovation outcomes.
I learned the importance of combining multiple low-power energy sources to ensure system license. The project helped me balance technical ambition with human-centered design. The case studies reinforced structured thinking, creative freedom within constraints, and the importance of fostering a cooperative, innovative culture.
As a group, we developed a strong understanding of innovation as a structured and continuous process. Through the case-based learning, we learned to identify real-world problems, balance creativity with feasibility, and integrate sustainability considerations into design. The project strengthened our communication, shared relationship, and ability to translate theoretical concepts into practical, real-world solutions.
Thank you for your time and attention.